Greetings, this is Russ Andersson with a quick run-through of the automated tracking and solving capabilities in SynthEyes 2008+1. I'm going to start out by opening up a shot. And because it's a stereo shot, I'm going to tell SynthEyes that there are two views of it. And we'll open first the left and now the right. And we can switch back and forth between them now if we like. So we're going to proceed directly to a automated track. Get to select one of the different modes. Just a straight stereo mode that we're using here. So right now it's going and doing the tracking on each of the views independently, as well as finding the relationship between the views in 2D. Once it's completed that, it's going to start off with the 3D solve to figure out where the cameras went and where everything is. And sure enough, we wind up with a camera solve. You can see each of the different views. We need to go ahead and set up a coordinate system now. So just to do that, this particular shot, we just need to make sure that we get some of the trackers that are up or on top of this bridge rather than down underneath it. So I'm just going to pick this view here. And now you'll see I need to be sure to add the constraints on what's the dominant camera. In this case, SynthEyes is configured for the right camera to be the dominant. And now I'm going to try that again. And I'm just going to pick out my trackers. And now we've just snapped the scene onto the ground plane. That's the top of that little bridge. So we can go over to the perspective view if we wanted, and we'll lock to the camera view. And now we could go and go to somewhere where you can see. We'll select a teapot. We'll drop a teapot in there, maybe we'll rotate it around. Now you can see it's tracked into the shot in both of the different views. So that's your super basic fundamentals. Let's take a look at this in more detail and see what we've got. So far we haven't really configured anything that has to do with the relationship between the two cameras yet. So SynthEyes has linked the two cameras together, but it hasn't set up anything that has to do with the relationship between the two cameras. And if you look at this particular set of tracking data, you'll see that at the end, the two cameras start to pull apart a little bit more. And that's something that could happen, depending on what kind of rig you have. This is just a metal plate, so that's not going to happen. So in SynthEyes, there's a panel that lets you control all the 6 degrees of freedom between the two cameras and select a different mode for each of those axes. So the first fundamental value there is the interocular distance between the two cameras. You'll also might recognize the divergence angle between the two as well. But then we also have 2 other degrees of freedom in the relative positioning, as well as the relative tilt and roll of the two cameras. So what we're going to do here is we're going to start saying that we have a known interocular distance. I just pick at random here pretty much. And let's see what we need to do about that. Now, here, a known interocular distance sets up the scale of the scene all by itself. Now, the coordinate system that we set up originally also contained a sizing constraint as part of that *3 coordinate system setup. So we need to go and actually take out the scale constraint that we initially added, and that's really this y = 20 value. It's just implicitly setting up, basically a random but fixed size to the coordinate system. So here we're just going to say that that particular point that's being used as a size constraint really just needs to be on the y-axis somewhere without specifying a particular distance along the y-axis. So we're removing the distance constraint that is in the coordinate points and letting the distance constraint between the cameras be the thing that sets the scale of the scene. Now, if we'd done this in the other order and set up the camera parameters first, then when we set up the star 3, it would have done this automatically for us. But I just wanted to show sort of what's going on here. Now, if we go and refine the solve, it'll go and take advantage of the interocular distance that we've just set up. And on the stereo panel here, you'll see now the actual value between the two cameras over here, the 0.485, is the value that we've set, and it stays that way throughout the shot. If we go and zoom in on that shot again, you'll see that the two cameras remain at the fixed distance all the way throughout the shot. Now, the relative positioning of the cameras can be changing and is changing now, so we can go and select a bunch of different modes on those as well. So we might decide that we just know that everything is perfectly aligned to start out with, that we've calibrated everything super carefully and know what those values are. Or perhaps we've determined them from a different shot. So we could do that, or we could have SynthEyes go and use figure out what the best single value is for those parameters. So we'll just do that here, and now it's gone and come up with a average sort of value that keeps the error as low as possible. And one of the things you should notice is that each time that we go and add more constraints between the cameras, the error is slowly creeping up a little bit more because we're controlling where the cameras can go when really the tracking data is saying something else. So one of the things that you can do is go and look at the tracking data once you've started to get a solve going. You can actually go and look at some of the different trackers and see which are ones that have particularly high errors that maybe you want to just delete and then refine the solve again to improve it. So that's just one way to go and improve your solves over a period of time. So this is a basic introduction to stereo. There's plenty more as far as how to handle supervised tracking as well, which obviously you can do too, but we'll leave that for another tutorial. Thanks.